Hi, folks. Welcome to a new episode of the Next Iteration podcast. I'm Chance. I'm joined by Chirag.
Hi.
In this episode, we are going to talk about the test pyramid. Let me start off. Pyramids are from the Egyptian era. In the realm of software engineering, pyramid is a metaphor for different categories of tests. Uh, in the modern software era, good software is characterized by how soon do you get feedback if something goes wrong, and usually it's a matter of seconds, not minutes, not hours, and not days or weeks. And for that, you need to have a really strong test suite for you to feel confident to go live and for you to also make changes. And also, as people know, software systems are quite fluid because most things around them, from the software frameworks to user requirements to people in teams, keep changing. And that's where tests become a very important feature or a characteristic of a good software system. Now, let's talk about the test pyramid itself, like I mentioned. As you would see on the screen, it resembles a triangle shape. There are different sections of the test pyramid. Let me start from the bottom, Chirag. I'll talk about unit tests first. Unit is the most fundamental block of your software. It could be a method within a class, it could be a component on your UI. Uh, it could be something that is the least size within your application and something that can be tested in complete isolation. So when you write unit tests, typically uh, what I call it as, you can run these tests even when your laptop is on flight mode. So they wouldn't need network access, they wouldn't need file access, they wouldn't depend upon any external system, and that's how they are, and that's their purpose. Because you could run a lot of unit tests in parallel. They wouldn't affect each other's state because they don't share state. You set up state in memory separately, like for each of them. Sometimes you bring in mocking frameworks if you are depending on something else. And it's very easy to set them up, run them, and tear them down. So typically, a unit test wouldn't run more than 5 to 10 seconds, and most unit tests run within microseconds. So I've seen good software team write a lot of unit tests, and the entire unit test suite completes within, let's say, 10 seconds. And that's the power of a very short feedback loop. Um, so, are we good with just writing a lot of unit tests? As expected, the answer is no. Uh, because there is a specific purpose for each of the tests. So, the next layer of tests that you will see in the pyramid are called integration tests. So, as the name suggests, you are testing two or more components together here. It could be class A and class B, it could be class A and service A, it could be class A and database A, or class A and cache, or something else, right? And you are now sort of making your size of the tests bigger because you want to see the interplay between these two components. And now typically you will have things like network access, file access, database access, and so on come into play. Sometimes you also need to have a sleep as well, because you need to wait for some action to finish, and then you need to verify so you need to verify if that action has actually been completed, right? And integration tests typically can be narrow, or they can be broad, right? Narrow as in you will use frameworks like wiremock to like mock out service dependencies. You will use libraries like h2 to create in-memory databases. So though there's a notion of dependencies, you're essentially so you are able to control how these dependencies behave, and then you're able to test them in an integration mode, and then that's why the name narrow. The other option is to exercise all the dependencies in a flow, and that's why it becomes broad. So in the second category, you may actually host your dependent service. You may create data in a dependent database and exercise the whole thing in one flow. um, these tests are good to write to like verify these workflows or these sequences actually happen. And you cannot do this in like unit tests because you're essentially mocking out the dependencies, right? um, but also note that they take a little longer to run. There might be dependencies while running tests in parallel because they may share the same database, and they may be working on the same data. There could be limits that you hit when you consume the same service, or you may need to wait for a service to return data and so on, right? um, and just above the integration tests are API tests, and this is very specific to writing services or APIs, whereas integration could be two classes, it can be two components on the UI. So it's just a different nomenclature. And again, one call out here is that this is a representative test pyramid. This is not your test pyramid, and for each team they need to figure out the nomenclature and understand what is the scope of each of the tests that they write. Like I mentioned earlier, it could be network access, yes or no. It could be database access, file access. How long does it take? Can many tests be run in parallel, and so on, right? The next layer of tests is end-to-end tests, sometimes called functional, sometimes called regression, or like even system. So, as the name indicates, you are mimicking the user action here. If you have a web app, it's like a user has access to your web app. They have logged into it if required. They are able to execute the workflows, and then they're able to see the expected behavior on the web app. Sometimes it could be services as well, and again here your consumers are going to invoke those services and they're able to provide the required data and then see the actual actions happening that they expect, right? And it could be anything else as well. It could be a IoT application, it could be a AI agent, it could be a bad job. But in general, if you exercise your entire system is where it becomes end to end, as the name suggests. um, yeah, and then here take care or be aware that these tests take significantly longer to run, and are also not easy to debug when things go wrong because there are multiple points of failure. And also they need a lot of setup to be done. So that's the caveat here. But yeah, these tests do have their place because you're able to get confidence that your entire system works well. And typically they are reserved for the primary flows of the application. And last but not the least, you see a small cloud shape on the top, and that is exploratory or manual testing. Some things human beings are really good at. No AI or no ML algorithm can like mimic the way that we think and the scenarios that we are able to execute. So these are tests typically run by your subject matter experts, your business users, or people who are on the team and who understand the domain deeply. And as part of your regular application development or your testing phases, I would encourage to still have a place to do exploratory testing, right? And again, this is manual, so this could be subjective, it could be error prone in terms of how you record the test results, and therefore your effort to replicate that test defect might be quite high as well, and sometimes it could be very difficult to actually even replicate it as well. But again, like human beings could open different tabs, or they may be able to sense like colors, and especially in terms of accessibility and usability, they may be actually be able to test your application from a remote place where the network speed is quite slow, and so on. So there are definitely places for doing this. Yeah. So this is what a typical test pyramid looks like, and these are all the different layers that you would see. Now let's understand the purpose better and then go into the details a bit more. Chirag, so now that I've spoken about the different tests and also talked about what they entail, do you want to maybe talk about the nuances on why do we actually need a test pyramid and what do each of these tests do?
Yeah. Yeah, thanks. So since you've covered like what each of these tests types stand for and what value they provide to a team, but now let's talk about why they are placed in the pyramid in the way that they are, right? The idea of this pyramid uh, visualization is to show the fact that you want to have a lot more of the tests that are at the bottom and a very
Mm,
few of the tests that are towards the top of this triangle. So the idea is that unit tests are the ones that you want most in number in
mm,
your test suite, and um, like like it's quite normal for elite software teams to have thousands of unit tests written within 3-4 months of development um, effort on a project. So unit tests would typically be in thousands, and so you want lots of these unit tests. Then you want a few, relatively to unit tests, you want a few integration tests. Then you want even fewer API tests, and you want just a handful of end-to-end tests, and a
mm,
handful of effort spent on exploratory testing. So that's the idea of the shape of this pyramid. But yeah, let's then talk about uh, why is that valuable? And this relates to what Chans you were already mentioning, that the whole idea of a test suite is to find a way to reduce the feedback loop, to increase the frequency at which you get feedback and the speed at which you get feedback.
mm,
And the beauty of unit tests, especially, is that because they are just testing one class at a time, typically, and possibly even, yeah, just one class at a time, all in memory without any dependencies, and
yeah,
so on. You are able to one write these tests very easily, uh,
true.
as compared to any of the other tests. And you once you have these tests written, they run extremely fast. Like a single unit test will run within microseconds, and like hundreds of unit tests will run within milliseconds, and uh, and that is really powerful. So even when you have 10,000 of these unit tests, you will still be
Mm,
able to run all of them within a few seconds. And so that's really powerful as a developer when you're writing a new piece of code. Let's say you add some tests, you add some code, you following the TDD cycle, and once you're satisfied, that the new tests that you've written and the new code that you've written works, then you could just run all of the unit tests within your IDE, and they'll run within a few seconds and
mm,
give you the confidence that you haven't broken anything. And in case you have actually broken anything, the other good thing about unit tests is that it will be extremely sharp in pointing to you as to what is broken and where the source of the problem may be, because it'll,
mm,
like, a particular test will fail, and you'd be able to know which class, which method it is exercising, and thus to then figure out what the problem is and how to solve it becomes really easy when you get that feedback back from unit tests that the team has written. So that's why unit tests are just so valuable to write, and that's why we would recommend teams all the time that they should write as many of unit tests as they can. Whatever can be tested at a unit level should be tested at a unit level only, and not at any other levels.
mm,
You have to reserve all the other tests, other kinds of tests, for something specific that can't be tested just at unit level. So take integration tests, for example, that you have, let's say, a functionality that depends on some external service, some third party API, and so
mm,
on. So there, it's fair to say, okay, I can't just use unit tests for it, so then I'll use some kind of integration test, either the narrow type which mocks out
mm,
the external dependency, or a wide type that
mm,
uses the actual dependency. If it's important enough, then you will automate that kind of testing using integration tests. Uh, and that is, like Chans was saying, that has its purpose, but it's important that you keep, as a team, the number of such integration tests extremely small as compared to
mm,
unit tests. Because again, integration tests will take longer to run. They will, when they fail, they can be failing because of an issue with multiple of the components that you are testing in your application, or it could be
mm,
failing because of the couple of dependencies that you are exercising within this test. So there could be multiple sources of failure, and so even when something fails, it takes you longer as a team to figure out why it is failing and what to fix. So that's why they are less valuable in terms of giving you fast feedback,
mm.
and so you want to have fewer of them, uh, so that the overall time required to run the entire suite still stays small. And like that, for API tests, you want fewer of those API tests as compared to integration tests. And finally, when it comes to end-to-end tests, you want just a handful of them, 5, 7 at max.
Yeah.
And again, because they take the longest to run, because they would use the real database. They would use like a real sort of LDAP login.
Yeah.
If you're depending on that, they would go to some real uh, um, external dependency as
There's
well. And
cost
so
as
that,
well. Yeah.
yeah, and so there could be cost involved if you're like testing out payments and stuff
Yeah.
like that. So it's all real, and that is useful. Like Chance, you were saying earlier, that it gives you the confidence that, yeah, I've tested a few end-to-end flows, and I know that it's all sort of wired up properly. So that is valuable, but you don't need to run multiple different scenarios. You just need to run a few of the happy path scenarios, and you know that the wiring is done right. And because if you, yeah, again, if you have too many of these end-to-end tests, it'll take too long to run, and it will, again, when it fails, it takes too long to find out what is going wrong with
Yeah.
it. And similarly, on exploratory testing, while it should only be reserved for the kind of scenarios that humans, with good intuition and good knowledge of the domain, can test things out in an exploratory fashion. Uh, but the idea is to do very little of that at at critical points in the project's journey. So that's
Awesome.
what you're really trying to do with test pyramids, that you're trying to write different types of tests, because each
Mm,
of them give you confidence in different ways, but you're still trying to do it in such a way that the overall time required to run the entire test suite is kept to a minimum. And you do that by making sure that you write thousands of unit tests and only a handful of every other kind of test. And
makes sense.
so when teams are able to do that, they're able to get validation from running their entire test suite within a couple of minutes, within 5 minutes, within 7 minutes. And that's
Mm,
what you're really aiming to do, because then you can run such a continuous integration, um, with the entire test suite 20 times in a day, 30 times in a day. And as soon as something gets checked in, which has accidentally broken something, or even before people check in, people can, take that 5 minute to run the entire suite. And in case something does go wrong, it gets flagged up really quickly, and then can get fixed quickly as well at the least cost. So yeah, that's
awesome.
what we are trying to do with the test pyramid. Um,
So, one question, Chirag. Do you recollect any anecdotes connected to the test pyramid?
Yeah, yeah. I remember this was a long time back when Selenium was very new,
Mm,
and our team had a bunch of QAs. So we were maybe like 10 developers and 4 QAs or
mm,
something like that. I remember vaguely, and the Selenium like web automated web flow kind of testing was new and very exciting for all of us,
Yeah.
but especially for the QAs, because now instead of relying on record and playback tools, they could write scripts to reliably, like, as compared to record and playback tools, with Selenium, you could
Mm.
drive web applications with much more confidence, right?
Yeah.
So so yeah, so they started doing the right thing, which is explore using Selenium to start writing end-to-end tests. But in a few months, we realized that the number of end-to-end tests was clocking up really fast. So within like 3 or 4 months, we had like some 25, 30
Wow.
end-to-end tests. And then we reached a point where every story, as part of every story, we started to have an expectation that it will that there will be an end-to-end test that will verify whether the story, acceptance criteria is met. So every story started to have like 2 3 additional end-to-end tests getting added, and soon we realized that it was a huge problem, because now the end-to-end tests itself started to take 30 minutes or
Yeah.
40
Easily.
minutes to run. And we also started to realize over time that even with the best, and now the sort of end-to-end test tools are even better,
Mm.
but they end up being much more flaky than the other types of tests, right? They'll fail
True.
for multiple reasons. They'll take a long time to run. They will also fail for multiple reasons, and when something fails, it takes a long time to identify why it is failing. So we started to reach a point where uh, developers, like, we had to just create different test suites. One was a test suite that developers would actually run before check-in, which would be primarily, unit tests and integration tests that the developers had written.
Mm.
And we started to exclude the end-to-end tests from that run. And end-to-end tests would only run once a day, or overnight,
Wow.
and it would take, eventually, we reached a point where it would take 3 4 hours to run. So you would sort of run it before leaving for the day and come back next day to see whether it ran successfully, and so on. And all that is just wasteful. It sort of ended up being this scenario where a lot of effort was being spent in writing these end-to-end tests, and in often, when something fails, which would be often every day, some random test would be failing, and you'd debug it, and most often you'd find out that it was a false alarm, that something was just wrong with how the data was set up, or how some dependency was set up, and used to
Then you
be
lose
just really
confidence in the tests, I
frustrating.
think.
Yeah, so you just start losing confidence in tests,
Ah,
and your confidence in the idea of automated testing itself being useful.
yeah. That's
and
even scary.
and and so yeah, at some point we said, look, we need to do something about it. And that's when we started to rationalize and think harder about what is the purpose of end-to-end tests. And then
Mm.
we used to have this thing that end-to-end tests are only for the happy path scenarios, and not they are not the way to test all, test all the variations and so on. They
Yeah.
all ought to be done by developers using unit tests and using integration tests. And QAs need to focus on exploratory testing, cross-functional testing. Like, that is what is more valuable to focus on.
Agree.
So yeah, so that was a lesson we learned the hard way. Uh,
Awesome. Thank you. Thank you, Chirag. All right, folks, let's summarize this episode then. We have come to the end of it. We spoke about the test pyramid as being a metaphor for different categories of tests in software engineering. We went through the different test types as well, such as unit tests, integration tests, API tests, end to end tests, and exploratory tests. Then we not only understood the purpose of each test, but we figured out how to leverage each of these layers and the entire test pyramid to your advantage in terms of which layer to leverage so that you can run your tests fast, which layer to use for like what purpose, and so on. And Chirag also helped us understand how to maintain the whole test pyramid as a shape via the numbers of the tests within the each of the layer, else it quickly gets out of shape. And then why is that so important? And Chirag also narrated a beautiful story on how easy is it to get swayed by one type of testing, and then you would end up sort of creating a hurdle for yourself, and how to continuously refactor tests, and how to write high value tests in general. So yeah, let's wait for the next episode where we will talk a lot more about the test pyramid. Thank you folks, that's all. Bye.
All right.